Good morning everyone. My name is Vaishnavi Bharadwaj. I'm a student of BCA AKU second sem and today I am here to solve a question on page replacement algorithm. First we have to understand what is page replacement algorithm. Page replacement algorithm is a very important part of virtual memory management and it allows operating system to decide which memory page will be removed or it will be moved out to give a space for the current page. Now we'll be solving the question on based on FIFO, which represent first in first out. We have a reference string over here and frame size. According to these columns are the frame size. So we have frame size 4, and now we'll be solving the question. First, the reference string is 7, so we'll take it as 7, and it will be fault. Until and unless we don't have a reference string in the memory space, it will be considered as a fault page, and we have to find how many page faults are there. First 7, since the memory space has not been completely full, so it will be considered as a false page fault. Now another is 7, and we'll be continuing it with 0. So this is also page fault. Now 7, 0 and 1. This is also page fault. Now we have 7, 0, 1, 2. Now it has completely fulfilled the memory space, but it is still in page fault. Now we'll continue the same numbers. Since 0 is in the memory space and we have 0 in the reference string, this will be not considered as page fault. Now we'll be continuing this process to the others. Now 7, 0, 1, 2. Now we do not have 3. We have reference string as 3, but we do not have 3 in the memory space, so we will convert it. So here we will be cutting it diagonally. Now we'll cut here as 7 and put 3 over here, and still it will be in page fault. Now we'll be repeating the numbers. Now we have reference string 0 and we have 0 in the memory space, so it will not be page fault. Now again we'll repeat the numbers in the next column, and we do not have 4 in the memory space, so we'll cut 0 over here. As I already said that we have to cut it in a diagonally form, so 0 will be cut as here and it will get us 4. Now it is also as page fault. Now we'll repeat the numbers and we'll see that we have 2 as a reference string and we have 2 in the memory space, so it will be not considered as a page fault. Now we also have 3 in the page memory space, so it was also not a page fault. Now we continue, and here we do not have 0 in the memory space, so one of the numbers will be basically deducted and will be replaced with 0. Now this is also in page fault. Now we'll repeat the numbers, and now we have 3 in the number, so this will be considered as no page fault. Now we'll repeat it again, and we have 2 in reference string and memory space as well, so this is also not page fault. Now we don't have 1 in the memory space, and we will replace it with 2 and we'll get here as 1. So now this is also page fault. Now we have here the numbers as, now we have 0 in the reference string and the memory space, so this will be not considered as page fault, and we'll repeat the numbers again. Now we have 1 in the memory space accordingly to the reference string, so this is also not a page fault. Now we'll repeat again the process that we have been doing. So now we don't have 7 in the memory space according to the reference string, so we'll cut it again or replace it with a number, but since we have cut it diagonally, now we'll start from here. So we'll replace 3 with 7, and this will be continued at page fault. Now the numbers over here will be repeated as, and we have 0, so this is not a page fault, and again repeat all the numbers in the last column, and we have 1 in it, so we'll get, so this is how we solve the FIFO question, and now we'll continue. We'll count how many page faults we have got. So we'll count that here we have 4, 5, 6, 7, 8, 9. So total we have got 9 page fault in this question. Thank you. That's all from my